Slope of a line. The slope of a line connecting the points x of 1, comma y sub 1, and x of 2, comma y sub 2, where x of 1 does not equal to x of 2 is equal to. So now we have the slope formula. M is equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. The slope tells you how steep a line is. So we're going to look at example 1. Find the slope of a line determined by each pair of points. We have negative 1, 5 and 3, 2. Now there are two ways that we can find the slope. Well, we can plot the points and then we can count how many spaces up or down, left or right, that it would take us to get to the second point. So let's try that. We have negative 1, 5. And we have 3, 2. So we're going to connect the points. Now remember, in the previous section of chapter 3, we talked about that there were 4 types of slopes. We have a negative slope, a positive slope, an undefined slope, and a zero slope. So this section that we're doing right now, this example that we're doing, is some review. So to find the slope, we can start at 3, 2, and we want to find how many spaces will it take us to get from 3, 2 to negative 1, 5. So we're going to count. We have 1, 2, 3, so it's taking us 3 units up. And remember, the slope means rise over run. Rise meaning we can go up or down. Run means we're going to go left or right. So we're going to rise 3 units. Since we moved up, that's positive 3. And then we want to go to the left. We're going to count over. 1, 2, 3, 4. So we ran 4 units to the left, so because it's to the left, it's negative 4. If you wanted to, you can start at negative 1, 5, and how many spaces will it take us up or down, left or right to get to 3, 2, and what's going to take place is that our rise, since we're going down, it will be negative. And then our run is going to be positive because we're running 4 spaces to the right. And running to the right means we're going to the positive direction. So our slope is the same no matter which point we start from. Now, so we've drawn those 2 points, connected the dots, and found the slope that way. And then we can also use the slope of the line formula. M is equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. And the points that we're using again, negative 1, 5 and 3, 2. So keep in mind our ordered pairs are always x and y, x comma y, but how we label the points, we're talking about 2 different sets of points. So the first set of points, we're going to label that with the subscript of 1. The second set of points with the subscript of 2. And then we're going to substitute. We have here 2 minus 5 all over 3 minus negative 1. Our numerator, 2 minus 5, we have negative 3. Our denominator, 3 minus negative 1, which is positive 4. So we have the same slope. And remember, we read a graph from left to right. We read a line from left to right. And notice that our line is going down. As the x increases, our y coordinates are going to decrease. So we have a negative slope. Example 2. Find the slope of the line determined by each pair of points. We have 8, negative 7, and negative 10, negative 7. We're going to use the slope of the line formula. M is equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. So we have negative 7 minus negative 7 all over negative 10 minus 8, negative 7 minus negative 7. Those two negatives will give us a positive. And we have negative 7 plus 7, which is 0, over our denominator, negative 10 minus 8, that's negative 18. And 0 divided by negative 18 is 0. So we have a 0 slope. Okay? So what this is saying, that we are, for our rise, we're not going anywhere, but our run, we're going left to right. So we have a horizontal line. Horizontal lines has a 0 slope.